Let's talk about speed, specifically, why boats and planes use knots instead of miles per hour. It's a detail you might not notice at first, but it's a fascinating window into how humans have navigated the world for centuries. Whether you're crossing the ocean or flying above the clouds, the way we measure speed is more than just numbers on a dial. It's a story of exploration, survival, and ingenuity. You hop in a car, check the speedometer, and see MPH. It's simple, familiar, and tied to the roads we drive every day. Miles per hour makes sense for highways and city streets, where distance is measured in miles and time in hours. But step onto a ship or into a cockpit, and suddenly it's all about knots. The numbers look different, and the language changes. Why do sailors and pilots use a measurement that seems so out of place compared to our daily lives? The answer goes back to a time when crossing the ocean was perilous, and navigation was a matter of life and death. Back then, knowing your speed wasn't just about efficiency, it was about survival. Storms, shifting currents, and uncharted waters made every journey a challenge. Knots aren't just sailor slang. They're a direct link to centuries-old navigation. The term comes from a practical method sailors used to measure speed, involving a rope with knots tied at regular intervals and a simple wooden board. Before GPS, sailors relied on clever, hands-on tools to measure speed and distance. They'd toss the log line overboard, count the knots that passed through their hands in a set time, and calculate how fast they were moving through the water. It was a blend of skill, timing, and tradition. A knot is 1 nautical mile per hour, and a nautical mile is tied to the very geometry of our planet. Unlike a regular mile, a nautical mile is based on the Earth's circumference, specifically 1 minute of latitude. This makes it perfect for navigation, since charts and maps are drawn with latitude and longitude. This system made plotting a course on a chart practical and reliable. It allowed sailors to translate their speed directly into distance traveled across the globe, no matter where they were. Even today, with all our technology, knots remain the standard for ships and planes. GPS and computers have made navigation easier, but the knot is still the universal language of speed at sea and in the air. It's a testament to the enduring power of a simple, ingenious solution. The knot connects us to a long tradition of exploration and discovery, reminding us that some ideas are simply too good to leave behind. So let's unravel the story of the knot, a measurement born from necessity and still vital today. It's more than just a unit, it's a symbol of how we've learned to master the world's vast oceans and skies. By the end, you'll see why this old idea is still going strong, and why, when it comes to navigating our planet, the knot is here to stay. Imagine being lost at sea. No landmarks, just endless water. For centuries, sailors faced this terrifying reality. Their biggest challenge? Figuring out where they were. They used dead-reckoning tracking direction and speed from a known point. Direction was manageable, with the sun, stars, or a compass. But speed? That was the real problem. You can't judge speed by looking at the waves. A small error could mean missing land by hundreds of miles. Without a reliable way to measure speed, navigation was guesswork, and lives were at stake. Mariners needed a simple, repeatable method to measure how fast they moved through water. The solution? A rope, a piece of wood, and a clever system that would change navigation forever. This is where the story of the knot truly begins. Let's see how they did it. Out on the open sea, sailors faced a constant challenge. How fast were they really moving? To answer this, they invented the chip log, a simple but brilliant tool that changed navigation forever. The process began with a weighted wooden chip shaped like a quarter circle, which was tossed overboard to act as a fixed point in the water, resisting the pull of the moving ship. Attached to this chip was a long, sturdy rope called the log line, carefully wound on a reel to ensure it would pay out smoothly and not tangle during the measurement. The first section of the rope, known as the stray line, allowed the chip to drift away from the turbulent wake of the ship, ensuring a more accurate reading. After the stray line, knots were tied at precise intervals along the rope. Each knot represented a specific distance, calculated to match the timing of the sand glass. Measuring speed was a true team effort. One sailor managed the reel, letting the rope run freely, while another kept a close eye on the sand glass timer, ready to call out when time was up. As soon as the stray line disappeared into the sea, the timer was flipped, and the log line began to pay out, streaming behind the ship as it moved forward. During the timed interval, sailors counted the knots slipping through their hands, each one marking the ship's progress through the water. It was wet, gritty, and sometimes cold work, handling soaked rope on a pitching deck, but it gave them the crucial number they needed, their speed in knots, a term that comes directly from this method. This hands-on method was ingenious, practical, and absolutely vital for survival at sea. Without it, sailors would have been lost, unable to judge their progress or plot their course. For centuries, the chip log was the backbone of maritime navigation, guiding countless ships safely across vast oceans and into unknown waters, all from a bit of rope, a piece of wood, and the teamwork of determined sailors, proof that sometimes the simplest inventions can have the biggest impact. Here's how it worked in action. Imagine yourself on the deck of a creaking wooden ship, the salty wind whipping past as the crew prepares for a crucial task. Every sailor knows that measuring speed is not just a routine, it's a matter of survival, especially when land is nowhere in sight. The chip floated behind the ship, trailing on the foamy wake, while the stray line paid out steadily. A colored rag tied to the rope marked the starting point, fluttering as it slipped overboard and signaled the beginning of the measurement. At that exact moment, the timer, a 28-second sandglass, was flipped. The grains of sand began their silent race, each second precious as the ship surged forward. As the sand ran, sailors focused intently, counting the knots as they slipped through their calloused hands. Each knot was a marker of distance, a small but vital measure of the ship's progress. Each knot was spaced exactly 47 feet, 3 inches apart, a number carefully calculated to match the nautical mile and the timing interval. This precision was the result of centuries of seafaring experience and mathematical ingenuity. When the last grain of sand fell, the number of knots counted told the crew the ship's speed in nautical miles per hour. It was a moment of anticipation, as every voyage depended on this simple reading. No math, no conversion, just a direct reading, clear and immediate. Even in rough seas or under starlit skies, the method remained unchanged. Afterward, the crew hauled in the wet rope, coiling it carefully and resetting the chip log for the next measurement. This teamwork was essential, and every sailor played a part. This ritual was repeated day and night, every hour on every voyage, rain or shine, calm or storm. It became a rhythm of life at sea, a heartbeat that kept the ship on course. It was simple, reliable, and absolutely essential for safe navigation. Without it, sailors would be lost in the vastness of the ocean, with no way to know how far they'd come or how far they had to go. The chip log and sandglass turned the vast, uncertain ocean into something sailors could measure and master. These humble tools gave them confidence and control, even when the world around them was unpredictable. That's the power of a good idea, transforming uncertainty into knowledge and turning the endless sea into a path that could be followed home. But what exactly is a nautical mile? Unlike the land-based mile, a nautical mile is rooted in the Earth's geometry. It's defined as 1 minute of arc along a line of longitude, directly tied to the planet's shape. This made it perfect for navigation charts marked in degrees, and minutes match the distances sailors traveled. 1 nautical mile equals about 1.15 statute miles, or 1.852 kilometers. So, a ship moving at 10 knots is actually going about 11.5 miles per hour. The nautical mile and the knot were designed to work seamlessly with global navigation. This system made plotting courses and calculating positions much simpler and more accurate. That's why, even today, the nautical mile and the knot remain the global standards for sea and air travel. It's a system built for the world itself. You'd think new technology would make knots obsolete, but the opposite happened. Mechanical logs replaced chip logs, but still measured in nautical miles and knots. The entire world of navigation, charts, training, communication was built around this system. Switching to miles or kilometers would have made things more complicated, not less. So, knots stayed. When aviation took off, pilots faced the same challenges as sailors, navigating vast distances with no landmarks. Air navigation adopted nautical miles and knots, uniting sea and sky with a common language. Today, every cockpit and ship's bridge still uses knots. The tools have changed, but the logic remains. It's a rare example of a tradition that's both practical and enduring. Sometimes the best solution is the one that's already stood the test of time. In our high-tech world, the knot endures. Every time a pilot or captain calls out their speed, they're echoing a centuries-old tradition. The knot connects wooden ships to modern jets, a thread of ingenuity running through history. It's more than trivia, it's a lesson in creative problem-solving. Sailors solved a life-or-death challenge with simple tools and sharp minds. Their solution was so perfect, it's still the global standard. The knot is a tribute to human ingenuity, measuring not just speed, but our ability to adapt and endure. Sometimes the old ways really are the best, and that's a story worth remembering.